Hi all, welcome to another Old Man in His Shed video. Hopefully today I can't break anything, but we will see. Right, in front of me we have 7 rolls of solder. I, like many, am not overly keen on lead-free solders. I prefer a leaded, and so over the years I've collected a few spools. Difficult to buy nowadays, so when I see it available I grab some. In front of me we've got a selection of 7. Number 1 is a generic, supposedly lead-free solder that's commonly sold on likes of eBay, AliExpress, Banggood. It's a 6337 mix, which supposedly gives you a quicker transition between the molten and the solid state. Not sure why you would want that, but that's the reason for it. All the rest are supposedly 6040s. Next we have another Chinese brand, Kaizi, possibly. This again was an eBay brand. Next to that we've got a Loctite. Loctite and Multicore tends to be the same product. I don't know whether Loctite bought out Multicore or what, but it used to be called Multicore. You'll now see it under the Loctite brand. That's this one. Number 4 was sold on, I bought from eBay, and it was sold as a multi-core brand, a solder. We shall see in a moment whether that's true. Number 5 is a very old spool. It's at least 20 years old, supplied by RS Components. It's not been stored in the best of conditions in the back of a damp shed, so we'll see if age and damp has affected anything. Number 6 is a roll of solder supplied many years ago by Maplins, another UK big supplier who's sadly no longer what they once was. Number 7 is a random spool of solder picked up at a local boot sale. Judging by the red spool, perhaps it's going to be another multi-core, but we'll find out. Anyway, we'll have a look under the microscope, see what the flux core looks like, and then we'll do a bit of soldering. We'll first solder blobs onto a PCB, see how it melts, see what the blob looks like, and then we'll do some real world component soldering. This is through hole components, some resistors on a piece of Vero board, and we'll see how that works. Soldering iron I'm going to use is a generic T12 with a reasonable, I think it's a 4mm tip, just to keep plenty of heat in the tip, so that the soldering iron doesn't affect anything. Let's turn the soldering iron on. We'll start soldering at 300 degrees, that's my favourite temperature, and we'll see how we get on. Right, let's move these out of the way. Right, let's start with number 1. It says it's a 0.5mm. Get the older gauge out. 0.57, so not far off. We slice the end at an angle. Should give us a nice view under the microscope. Let's switch to the microscope. Now, if I can hold this steady enough under there. There it is. Right, get it in focus. Right. Oops. Cool. Not an easy job, is it? Right, come here. Right, we can clearly see I've got my left and right, so my back to front wrong here, and I clearly see that's a single core. Single core of flux straight down the middle. Right. So, how does it solder? These are all supposedly sub 300 degrees melting point, so they should all solder fine at 300 degrees. Melts fine at 300 degrees on the iron. Doesn't like going on the board though. That to me. Now let's turn this other light off. There we go. That's a bit better. I'll tell you what. Let's do it under the microscope. Focus. There we go. Here we come. Well, as you can see, it's not soldered very well, is it? Try that again. It melts fine on the soldering iron. But it's really not soldering very well on the PCB. Right. Let's move on to the next one. Next one is this Deg, possibly how you pronounce it, I'm not too sure. This one is a thinner one. It's supposedly, what's it supposed to be? 0.3, and it measures 0.36. So again, not far off. Solder test. Go to the microscope. Again, melts fine on the iron. Onto the copper. Quite thin, so we've got to feed a lot in. Again, that's not soldering very well. Right. Number 3, Loctite. This one is 0.7. Where it says on the tin. Measures 0.67. So it's a slightly smaller. Oh, we didn't do the flux test on this one, do we? Let's quickly do the flux test. Under the microscope. Focus down. Again, that one. This is the Deg one. You can see it's a single core flux. Now over to the multi-core. And the multi-core, you can clearly see 5 cores of flux in there, which is why it's called multi-core. Right. Focus back down. Suppose I get the focus. Right. Again, melts fine on the iron. Feed it in. And this time you can see it clearly soldered fine at the 300 degrees. Pool of flux around the joint. The joint is nice and smooth, nice and shiny. Right. Number 4. Number 4 is quite a thicker solder. 1.2 millimeters. I can see this with the naked eye. This is focus down. Oh, where are you? Come here. There it is. Oh, there you go. Yep. That's definitely a multi-core solder as well. So expect that to solder pretty much like number 4. And pretty much identical to number 4. Confirming, yes, that's definitely multi-core branded solder. Right. Number 5, which is the RS branded. Did RS go to multi-core for theirs? This is measuring 0.66, so probably a 0.7 it was sold as. We can have a look under the microscope for this one. Where's my focus point? Nowhere. Gone too far perhaps? Here we go. There we go. Yeah, looks like RS went to multi-core for their brand as well. Right. So we should see this being looking the same as, well, this is one that's been in the shed for 20 years, so whether or not damp has affected it, we shall find out. Feed in a nice big blob. Yep, typical multi-core look. Doesn't look like the damp has affected it. Right, then on to number 6, the Maplin one. Maplin one again is quite a thick one. .14, so probably a 1.2 millimeter. Don't really need the microscope to see this one. That's a single core, so they certainly didn't go to multi-core to get their solder made. You can clearly see there's a single core of flux in it. Let's see how it solders. on the tip. Melts fine. Need to feed in quite so much. It's almost indistinguishable from multi-core solder, so that's a good quality solder. Now the last one, number 7, the unknown one. This is another one that's been in a shed somewhere, judging by its appearance. 0.5 millimeters. And we see what it looks like under the microscope. There it is. Zoom in on it, focus in on it. Yeah, that looks like a multi-core solder as well. So don't expect that to give us any issues in soldering. Just to confirm it. Oops. Yep, that's fine on the tip. Feed a load in because it's a nice thin one. Little bit of a dirty look to the flux, so perhaps it's aged a bit too much. Let's try again next to it. Yeah, that flux pool around the outside looks quite discoloured, so I think the age has affected the flux, not the solder, because the solder seems to solder fine. Right, let's go back to the first two and try a different temperature on those two. Both claim to be under 300 degrees melting point, and they did melt at under 300 degrees on this tip, but not on the solder. So let's wind up the temperature. Right, wait for the iron to heat up. 350 degrees. Try number 1. Well, that's better, but it's got a very dry look to it. There we are, do number 2. Very thin solder, so I've got to feed a lot in. Oh, that's better, but it doesn't look like it's happy at that temperature. It's got to 400. Try number 1 again at 400. Be honest with you, the way the finishes on them, they look more like they're lead-free than leaded. Oh, look, the voice WhatsApp's gone off. Right, and then number 2. Going very thin, so I've got to feed an awful lot in to get this to show. Oh, It sort of sticks where it touches, but it doesn't flow very well, does it? A very matte surface. I wouldn't mind betting that 1 and 2 are more lead-free than leaded, which is the trouble with buying from certain places. The sellers are not known for being the most honest. But let's see what they perform like in the real world. Soldering components. Number 1. I'm trying. Head's a bit big, but soldering iron tip's a bit big for this, but I'll try. So if not, I'll change it. Yeah, skip. Hold on a second. I'll just change the tip first. Give it a second for the new one to warm up. We're still at 400 degrees for these. Right. Let's try again. Oops. That's not very impressive, is it? Wish that the last one's just not flowed around the wire. Oh. Okay, that's number 1. Number 2. Let's see how number 2 goes. Clean the iron. Reagent. Good Lord. Did we get the soldering all these resistor wires poking up? Come on, get in there. There you go. Right. Come on. There we go. Oh, that's... This actually have been slightly better. Right, let's take the temperature down for the rest, because they all seem to like 300 fine. Let's temperature drop on the soldering iron. Right. Now we're number 3, which is the Loctite brand. They look fine. Number 4 is the multi-cord unbranded. This is a bit too thick a solder for this sort of work, but we'll give it a go. Yep, 4 perfect solder joints. Number 5, the RS, which we suspect is also multi-core. The wires in the way. Bonk. That's number 5, again a perfect appearance, nice clearly soldered. Now we're going to the Maplin branded. Oh, I missed one out here somewhere. RS number 5. Number 6, Maplins. Again, no issues. A little bit thick for this type of work. But it's certainly soldering fine. Nice appearance. And lastly, number 7, the old, well, I'm sure is another multi-core. Assuming multi-core are the only people who manufactured multi-core solder. I could be wrong. It could have been other companies, and this could be made by somebody else. Just calling it multi-core because it's a multi-core. Same with number 4. It's a multi-cord solder. I'm assuming that means it's made by multi-core, or Loctite as they're now known. Right, here we go. So that's all 7 soldered. All of them apart from 1 and 2 flowed perfectly okay. Have a nice appearance. 1 and 2 really were not happy. May even have needed a hotter temperature than the 400 I used. I definitely wouldn't recommend 1 and 2. Okay, let's pull them all back onto the mat. 7, 6, 5, 3, 2. Change camera. Okay, so here we are. All of them back. I'd recommend any of them apart from 1 and 2. 1 and 2, I'm not convinced is lead-free solder. Anyway, hope this has been of help, and see you again in the next video when I try to break something. Bye.